Hello viewers, how are you all? Hope you are doing well. So today I have come with another interesting new video of our 3-dimensional geometry lecture series, lecture number 26. So today we are going to discuss the equation of a plane passing through the intersection of two given planes. So as usual we are going to understand this theory with the help of real life mathematical models. So let us welcome the beautiful and colorful mathematical models. So today I have considered these two books, this red one and yellow one, to demonstrate the two planes which are intersecting and keep them like that. Then it is very obvious that these two planes are intersecting, and this line is called the line of intersection. Now our main objective today is to find the equation of a plane which is passing through the intersection of these two given planes. To understand this abstract concept of 3D geometry more vividly, we will consider another plane, that is another book, and keep it here like that. Now you can understand it that this blue plane is passing through the intersection of the two given planes, that is red one and the yellow one. Now you can see that in such a way we can get infinitely many planes like that which are passing through the intersection of these two given planes, that is red one and yellow one. Then how to get a unique plane like that? To get a unique plane we must be given a particular point. So after proving the theory, when we are going to solve problems of this type, then you will be given in the problem that find the equation of a plane passing through two given planes, and a particular point will be given on this problem too. So what is the purpose of giving that particular point? The main purpose of this giving the particular point in the problems is that to get a fixed unique plane like that which is passing through these two given planes. So that's all for our mathematical model part. So let them say goodbye. Thank you, Mr. Models. First we will draw the diagrams. Here see this one plane in white color. Again I have drawn another plane with blue color. Name this as plane pi 2, this one as pi 1. Now this line is the line of intersection through which we have to find the equation of a plane which is passing through the line of intersection of these two planes, pi 1 and pi 2. Name this plane as pi. Now let the equations of the planes pi 1 and pi 2 are vector dot n1 cap equal to d1 and put this number 1, and r vector dot n2 cap equal to d2, where n1 cap and n2 cap are what? They are the unit normal vectors to the plane. Again here I have used the concepts discussed in our earlier lectures, mainly lecture number 20. So my humble request to you, as always, if you come directly to this lecture number 26, then please go through my all previous lectures, especially lecture number 20, that is equation of a plane in normal form. Then come to this lecture, then you will understand everything what I am telling about. So now as pi 1, not as here, pi 1 and pi 2 are intersecting planes. Let P be any point on the line of intersection whose position vector is T vector. Here I have taken one point, say in red color, P, whose position vector is R vector. Undo. R vector is the position vector of T vector, not R vector. T vector is the position vector of this point P. Now, this point P lies on the plane pi 1 as well as on the plane pi 2, because this point P is a point on the line of intersection, that is a common point. Also, you can understand, if I draw a plane passing through the line of intersection of these two planes pi 1 and pi 2, then the point P also lies on that plane also, that is, this point P lies on the required plane pi also. I think you have understood this step. If still you have any doubt, put your comment in the comment section below. Just see the explanation of today's video with the real life mathematical models, then you can understand it very easily, that P is a common point on all the three planes, as P lies on the line of intersection. Okay, so therefore T vector will satisfy both the equations. So T vector will satisfy both the equations 1 and 2. Therefore, T vector dot n1 cap equal to d1 and T vector dot n2 cap equal to d2. Therefore, any plane equation. Therefore, equation of any plane passing through the line of intersection of planes pi 1 and pi 2 is T vector dot n1 cap plus lambda times n2 cap equal to d1 plus lambda times d2, where lambda is a scalar. This, for each values of lambda we can get a equation of a plane. That is why while explaining with the mathematical models, I told you that for the intersection of two given planes we can draw infinitely many planes. But if you get a exact value of lambda, that is unique value of lambda, then you can get a particular point, particular plane. So to get a unique value of lambda in the problems, you will be given a particular point. That is the reason why in problems two equation of two planes are given and a particular point is given, and you will be asked to find the equation of a plane passing through these two particular planes and this particular point. So in mathematics, each and every word given in the problems has its importance or significance, you can say. So you have to read the problem very carefully while solving it, either in examination hall or in home. So lambda is a scalar. So now, as P is any point, so we can replace T vector by R vector. As P be any arbitrary point on line of intersection, next page, intersection, therefore the equation of a plane, here pi, which is passing through the intersection of planes pi 1 and pi 2 is r vector dot n1 cap plus lambda time n2 cap equal to d1 plus lambda times d2, where lambda is a scalar. So we are done. Now it is the vector equation of this plane. If we are asked to find the Cartesian equation, we will see it in the next page. So this is the yellow green color. So this is the vector form. Now to find the Cartesian form. Pages. Cartesian form. So how to find the Cartesian form? From here r vector r vector dot n1 cap equal to d1. We can write r vector we can write a 1x b1y c1z equal to d1, where a1 b1 c1 are direction ratios of unit normal vector n1 cap. From r vector dot n2 cap equal to d2, we can write similarly a2x plus b2y plus c2z equal to d2. Now simply just we have to write one equation plus lambda times other equation equal to 0. That is the required equation of the plane passing through two given planes, passing through the intersection of two given planes. So therefore the required equation of plane is a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 equal to 0, where lambda is a scalar. So this is the Cartesian equation of the plane passing through the intersection of the two given planes. One is red color, this one a1x plus b1y plus c1z equal to d1, another is this one. So this one plane pi 1, this one plane pi 2, and this one is plane equation plane pi. So we are done. Now we will see one application of this beautiful theory. Okay, next, previous page. This on the application. Find the vector equation of the plane passing through the intersection of the planes this and this. First we have to derive the vector equation, but we will first convert these equations into Cartesian form. That will be very beneficial. You can understand. If you solve it on self, then you can understand why I am converting these equations to Cartesian form. Then after deriving the equation, then we will again convert it to the vector form. Then it will be easy. Otherwise we have to repeatedly write I cap, j cap, k cap several times. It will take time. So here first equation of the plane is pi 1, say x plus y plus z minus 6 equal to 0. So read number 1. Second equation of the plane is pi 2 here 2x plus 3y plus 4z plus 5 equal to 0. Equation number 2. Therefore, next page. Therefore, here the equation of the plane pi through the intersection of two planes pi 1 and pi 2 b, we are going to next page. Take green color. Okay, so first plane equation x plus y plus z minus 6, x plus y plus z minus 6 plus lambda times previous page 2x plus 3y plus 4z, 2x plus 3y plus 4z previous page plus 5 equal to 0. Now we just take x 1 plus 2 lambda plus y, we take y as common 1 plus 3 lambda plus z 1 plus 4 lambda plus 5 lambda minus 6 equal to 0. For lambda is a scalar. You have to mention it in the examination paper. Okay. Then examiner will have no scope to cut a single number from your paper. So now here the point plays its role. See, for each value of lambda we can get a plane, but here in the statement of the problem it is clearly mentioned that the plane is passing to the point 1 1 1. So this point 1 1 1 will satisfy this equation, and when it will satisfy this equation we get a exact and unique value of lambda, and for this unique value of lambda we can get a unique plane which is passing through the intersection of two given planes. So now we just simply put the value of lambda 1 1 1 in place of x, y and z. I think you have understood. If still you have any doubt, please go through the video one more time. You can understand it very easily. Nothing is there. So 1 into 1 plus 2 lambda means 1 plus 2 lambda plus 1 plus 3 lambda. Again in place of y we put 1. Again 1 plus 4 lambda plus 5 lambda minus 6 equal to 0. Take white color. Okay. So now 2 lambda plus 3 lambda 5, 5 plus 4 9, 9 plus 5 14. Now 1 plus 2 3 and here minus 6 minus 3 equal to 0. So lambda equal to 3 by 14. Now we have to evaluate the values of this 1 plus 2 lambda, 1 plus 3 lambda, 1 plus 4 lambda, 5 lambda minus 6. Then we are done, because after evaluating these values we just simply put these values in this equation and we are about to solve the problem. So lambda equal to 1 plus 2 lambda means 1 plus 2 into lambda 3 by 14. So 14 plus 6, so 20 by 14. Okay. Then 1 plus 3 lambda. 1 plus 3 lambda equal to, take yellow color, 1 plus 3 into lambda means what? 3 by 14. So 14 plus 9, 23. Okay, 1 plus 3 lambda, then 1 plus 4 lambda. 1 plus 4 lambda. 1 plus 4 into lambda means 3 by 14. So 14 plus 12, 26 by 14. Okay. Now again 5 lambda minus 6. So 5 into lambda means 3 by 14 minus 6. Okay, 5 into lambda 3 by 14. So 15 by 14 minus 6. So its value will be 14 6, 84. 84, 15, 69. So minus 69 by 14. So we just simply put the values here. 20 by 14 into x, 20 by 14 into x plus previous page. 1 plus 3 lambda means 23 by 14 into y, 23 by 14 into y plus previous page. 1 plus 4 lambda means 26 by 14 into y, 26 by 14, 26 by 14 into z, not y, z plus next page, previous page, plus 5 lambda minus 6. 5 lambda minus 6 means minus 69 by 14, minus 69 by 14 equal to 0. We just multiply by 14 throughout. So 20x plus 23y plus 26z equal to 69. So we are done. Answer? No, it is the Cartesian form. Be attentive. In the question you are asked to find the vector equation. So again from this we have to convert this equation to the vector form. R vector dot 20i cap plus 23j cap plus 26k cap equal to 69. So now this is the required vector equation of the plane. Answer. So we are done. Now I will give one problem as home assignment. Similar type of problem. What is the problem? Here. Find the equation of the plane through the intersection of the planes this and this and the point 2 to 1. So this will be given as home assignment. If you are a serious student, then solve it and put the answer in the comment section below. It will motivate me a lot. Thank you for watching.